Hey, welcome to today's video. Today we're going to be looking at solving easier quadratic equations. Well, I say easier. It helps if you've seen at least one or two of these before you try them. You should have watched solving quadratic equations before you watch this one. Okay. So, solving easier quads, not quadrilaterals. Quadrilaterals. That sounds like a little duck. Quadrilaterals, but quadratic equations. Okay. Okie dokie. So let's try this one. There are two types, e.g. There are two types. The first type is when I've only got two terms on the quadratic. So 3x squared plus 2x equals 0. Okay? So when I've only got two terms, there's not a c term here. Remember quadratics, ax squared plus bx plus c. There's not a c term here, there's only an ax squared and a bx. If I've got something of this form, the most I can do is take out a common factor. Okay? So the most I can do is pull out, as much as I can, but the most I can do is pull out an x, because that's the only common factor there. And I'm left with 3x plus 2 equals 0. Okay, there's nothing more I can do with there. I can't put it into two brackets because there's no trinomial there. Okay, trinomial, binomial, 1, 2, trinomial, 1, 2, 3. Okay. So this is the most I can do. Now I get to this and I say, okay, great. Well, what does this give me? This gives me two options. Either x equals 0, because 0 times anything will be 0, or the brackets equal 0. 3x plus 2 equals 0. Those are my two options. So I've either got 0 times anything gives me 0, or 0 times anything gives me 0. Okay? Well, what does that mean? Well, there's my one answer. Done. Okay, x equals something. Finished. Nothing more to do there. Now I've got to work this one out, okay? So I've got OTOS to solve this, opposite to other side. 3x stays there, opposite plus 2 is minus 2, opposite times by 3 is divided by 3. X equals minus 2 divided by 3. So there's my two solutions. My two solutions are x equals 0 and x equals negative 2/3. Please note, x squared, I expect two solutions. Sometimes you'll get one, but it's actually a repeated solution. And sometimes you'll get none, okay? But they're actually imaginary solutions. But don't worry about that if you're in junior high or if you're up to year 10 or 11, you probably won't be dealing with imaginary numbers before year 12. Probably, okay? But there's my two answers, x squared, two solutions. Alrighty, let's take a look at a different type of easier quadratic. And this is the second type where you can get, there's only two terms. So, EG2. And I'm looking at 4x squared minus 144 equals 0. Okay, so I don't mind, it doesn't matter if you've got minus 144, okay, or if you've got 4x squared equals 144, it doesn't really make a difference. I like to get everything over, okay, because it's a quadratic, I want everything on one side, and I look at this and say, oh, okay, cool. Hang on a second, hold the horses. There's no bx here. There's ax squared and there's c, alright? So there's still two terms. So I say, okay, cool, there's no bx, so I can't take the common factor of x out. So I say, okay, well, what else can I do? Well, alarm bell should be ringing. That's a perfect square, that's a perfect square, that's a perfect square. So I should be going, oh, hang on a second, this is a difference of two squares. Even more cool is that's a factor of that. So there's two ways you could do this. You can either do immediately difference of two squares, or you can factorize out a common factor first. Let's do the factorizing out a common factor first, because sometimes by factorizing out a common factor, you might change this into a perfect square. Okay, so if I pull out the 4, alright, then what am I left with? Well, I'm left with x squared minus 144 divided by 4 is 36, okay, equals 0. Now again, difference of two squares. Okay, this should be obvious by now. Okay, so I've got this 4 sitting out in the front here. I've got the 4, right? And I'm going to factorize this into a difference of two squares. X minus 6, x plus 6. Okay, the order doesn't matter, as long as you factorize it into those two. Are you with me? So, where does this leave us? This leaves us two options. Either this one, x plus 6 equals 0, alright? Or this one here, x minus 6 equals 0. It's really, really useful, I find, to understand that why does this have to be equal to 0? Because 0 times anything gives me 0. why does this have to be equal 0? Because 0 times anything gives me 0. Are you with me? That's the principle behind splitting up the two linear factors that go into a quadratic. Look, linear, highest power 1, it goes into a quadratic. The two linear factors. So what you do is you're actually changing a quadratic into two linear equations that you have to solve, okay, by factorizing. You with me? Right. So, well, the answer for this, very straightforward. Opposite of minus 6 is plus 6, okay? Opposite of plus 6 is minus 6, okay? Now, the cool thing about these guys, and this is a little bit extra, then it's not on the notes. The cool thing about a difference of two squares, where the roots are symmetrical, 6 and minus 6, is that you get two roots. So this is the minus 6 here, okay? And this is the plus 6, all right? And what does that mean? That means that my whole graph of this guy, if anyone ever asks you to draw the graph, is symmetrical about the y-axis. So the y-axis is my axis of symmetry. Okay, that's kind of cool. All right. But we'll look at more plotting graphs of quadratics and how we actually do that a little bit later. Okay. But those are the only two options. Either I've got ax squared plus bx equals nothing, okay, so I don't have a c value, or I've got ax squared plus c equals nothing, so I don't have a b value, okay. In either case, the most you can do is common factor, okay, in both of them, or common factor in difference of two squares in this option. You with me? Okie dokie. Alright, there's more on the blog, more on the channel. Go check it out. Remember, I'm here for you.